Welcome to Mathematics Episode by SG Maths. Today, mathematics class, we are going to be considering 8 steps to solve SORT's problem. You're having challenges in solving SORT, or you don't even actually know the rudiments or how to go about problems regarding SORT. I believe after these 8 steps, you will understand it step by step, and you will be able to solve SORT's problem by yourself. Please do like and subscribe to this channel. Let's move on. The first one is understanding the meaning of SORT. Understanding the meaning of SORT. You must understand what we mean by SORT and everything that SORT entails, so that you will be able to solve any question related to SORT. And I want to tell you, SORT is one of the questions or topic rather. And I would love to tell you that SORT is one of the topic that is very interesting, that you will really love to know. The first thing you need to know about SORT is, what is SORT? He said a SORT is a root that cannot be expressed as a rational number. SORT is a root that cannot be expressed as a rational number. An example of such number is root 2, root 3, root 5. As you can see, if you carry your calculator and you press root 2, you get number that are into infinity. That is, it does not terminate. And when you press root 3, the same thing is applicable. When you press root 5, the same thing is applicable. So don't be surprised if you carry your calculator and you press, and maybe your own stop at one place and leave it. That doesn't mean it stop. When you get a higher calculator, you use again, you see the number continue. So the number does not terminate. Your calculator might terminate it, like my own here now. When I press root 5, I have 2.2360679777, but that is not where it stops. The number has to continue. So this will lead us to point 2, which is understanding the difference between rational numbers and irrational numbers. What are the rational numbers? And what are irrational numbers? How are you going to identify them? So let's go there deeply. We say rational numbers can be expressed as a fraction in form of p over q, and where p and q are integers, that is, p is an whole number, q is an whole number, and where q, which is in the denominator, is not equal to 0, because if it is equal to 0, you will have an undefined. So we said in rational numbers, decimal expansion terminates, and that is how you are able to differentiate. In rational numbers, decimal expansion terminates or repeats, that is, it reoccurs. An example of this number that terminates, 1 over 2. If you say 1 over 2, if you press the calculator, you give you 0.5, and that's the end. The number does not continue. And if you press 1 over 6, you have a 0.166666666. If you approximate that 6, you give you 7. So by that you can terminate it. It's not even the terminating in the sense of reoccurring, but what we see in this 1 over 6 is that we have 0.1 and the rest continue to be 6. 6, 6, 6, 6. So when you see number like this, you said the number is reoccurring, that is, it repeats. So any number that repeats itself like that is under rational numbers. And any number that terminates in decimal expansion is referred to as rational number. So let's see the second one. Irrational numbers. We said the irrational numbers cannot be expressed as a fraction of two integers. They cannot be expressed as p over q. No. And if you express them as P over Q, if you divide it, the expansion will neither terminate nor repeat. The decimal expansion neither terminates nor repeats. They won't terminate and they will not repeat each other. An example of numbers in form of these are root 2, root 3, root 5, even pi. Most prime number, fall into this: root 2, root 3, root 5, root 7, root 11, root 13, or root 23. So all these numbers, you can't terminate their roots. If you find the roots, for example, now let me say root 23 now, that is 4.7958311523. If you press the calculator, root 23 will give 4.7958311523, and the number still continue, it does not terminate. If you find pi, that is 22 over 7, if you say 22 over 7, 22 divided by 7, you will get 3.142857143, and the number still continue. It does not terminate and it does not repeat itself like 0.166666. So that is just the difference between a rational number and irrational numbers. For rational numbers, the expansion of decimal terminates or repeats, and for irrational numbers, the expansion of decimal does not terminate and it does not repeat. So let's go to the third one. For you to be able to solve SOD, number one thing is that you know that SOD deals with roots. The second one is you must understand the difference between rational and irrational. So the third one is you must simplify SOD. When you have SOD that is of large number, for example, let's look at this. Root 72. Root 72 we give us what? Root 36 times 2. You must simplify this 72. You must simplify the 72. 72 is very large, and if you want to find root 72, you might not get the actual answer for root 72 unless you simplify it. We just press root 72, you give me 8.485281,374, and that is not actually correct in SOD. It doesn't mean that the calculator is not correct. Yes, the calculator is correct, but you can simplify it further for you to get your answer in SOD form. And how are you going to do that? You said root 36 times 2, because 36 times 2 gives us 72. So when you find the root of 36 times 2, you're going to get 6 root 2. Then how do we get 6 root 2? Okay, let me explain further. We say root 36 times 2 will give us, separate that root, give 36 its own root, that is root 36, then multiply it by 2 also. 2 should have its own root as well. We have root 2. Then recall that this 36 can have the power of 2. That is, we can have it as 6 raised to power 2. That is, 6 can have the power of 2 to give us 36. So we have root, the main root, and 6 raised into power 2, which is going to give us 36, right? Times root 2. If you now take this 6 raised to power 2, the roots here, we cancel the 2 here, so that we will be left with 6, because the square will take away the roots. That's the rule. When you have square roots and square, they are like inverse of each other, so they will give you 1. That is, they will just give you raised in power of 1, and anything raised power 1 is that same number. So root will cancel the square root will cancel the square, and then we are left with 6. So multiply by 2, and that's why we have 6 into root 2. I believe we understand that. Okay, so try this. Try root 50. Just try root 50. Pause this video and try that root 50. Okay, for root 50, let me give you the solution. The same step, we have root 25 times root 2, and root 25 times root 2 give us 5 root 2. Then we say how. Now root 25 times 2 is equal to, separate it, root 25 times root 2. When you separate it like this, we have root 5 square, and root 5 square is multiplied by root 2. So like the other time, the square, we take away the square roots, and when the square take away the square roots, we have 5. That is how we have 5 root 2. So that's the third step. You must simplify your sword. You must simplify your sword, so that you will be able to get if there is a particular number that is perfect, like 25, we said perfect square. So you're able to get that perfect square. So for you to get that perfect square, you must simplify your sword. Okay, and then the next one is adding or subtracting only like sorts. Add or subtract only like sorts. You will only add or subtract sorts that are the same. Look at this. 2 root 3 and 5 root 3. If you look at the inner side, you see that the sword inside is root 3 and root 3. 2 has root 3 as its own sword, and 5 as its own root 3 as its own sword. So we have the same sword here, root 3, root 3. So when you have the same sword like this, you can add them together. So you have the one that is behind the sword, which is 2, and the one that is behind the sword on that side, which is 5. So 2 plus 5 give us what? 7. 2 plus 5 give us 7. 2 plus 5 give us 7. Okay, then we now have the root 3. So I'd not write root 3, no. You only pick one root 3. Then you plus the one that is outside, which is 2 and 5. When you plus them together, it give you 7. Then you pick root 3. So let's check the other one. 5 root 5 plus root 5. The answer is 6 root 5. If we want to ask why do we get root 5? Okay, we are able to get, how do we get 6 root 5 rather? We're able to get 6 root 5 because here we consider root 5 as 1 root 5. There is 1 here. There is 1 in this place. So that 5 plus that 1 will give us what? 6. And that's how we have 6 root 5. Okay, let's move on. for subtraction, we have 7 root 7 minus 5 root 7, which is equal to 2 root 7. The same thing with addition. You can only subtract sod that are alike. Okay, so 7 minus 5 gives us 2. Then you pick the sod, which is root 7. The same thing for the second one. 8 minus 1, there is 1 here, and then you must know that there is 1 here. Okay, then you put the 1 if you like. You can put the 1. So, but always note that when there is nothing outside, there is 1 there. So 8 minus 1 give us what? 7, and that's how we have 7 root 13. So we consider root 13 as 1 root 13. Please take note of that. Now the fifth step is multiply sod. Sometimes you have to multiply sod for you to get your answer. Look at this example. We have root 3 multiplied by root 12. For 12, 4 times 3 will give us 12, right? So it means that we can get a perfect square from 12, but 12 itself will not give you a rational number. So therefore, you will multiply that root 3 with 12, and when you multiply root 3 by root 12, you have root 3 times 12. Now 3 times 12 gives us what? 36. And when you find the square root of 36, you will get 6, because 36 is a perfect square. Okay, so you have to multiply sods. Look at that B also. We have root 5 times root 20. Multiply them together. 5 times 20 gives us what? 100. And when you find root 100, you get what? You get 10. So sometimes you have to multiply sod. You multiply the sods. Please take note of that. And the next one, you divide sod. That is step 6. You divide sod. Okay, let's look at this. A, root 12 divided by root 3 will give us root 4. And this is how it's root 4. If you have it as 12. You have it as 12 divided by 3. So you take all the roots together, put them there. You said 3 into root 12 give us what? Give us 4, and root 12 give us what? 2. The same thing is applicable to 36 divided by root 36 divided by root 4. So this one also, take it 36 divided by 4, and that will give you what? 9. That gives us root 9, which is equal to 3. When you take the square root of 9, you have 3. Okay, so let's go to the next one. The next one is rationalize the denominator. Rationalize the denominator. What does that mean? It means removing sod from the denominator. Look at this root 3. We don't want this root 3 to be in the denominator. Any number can be there except sod. Except sod. We don't want sod number in the denominator. And for you to do that, you will have to rationalize. And how do you rationalize? You rationalize by multiplying the denominator, which is this root 3, by the numerator. You can see we have root 15 multiplied by root 3, and we have root 3 multiplied by root 3. So you take whatever you have here, then you multiply it by both the numerator and the denominator. So when we multiply these together, we have 45, and when we multiply these together, we have root 9. We have root 9, and when you take the square root of 9, it will give you what? 3. To give you 3. Okay, and that's how we have root 45 divided by 3. Now root 9 multiplied by 5 over root 3. How do you get that? 9 times 5 will give us 45. 9 times 5 will give us 45 divided by what? 3. And with that, we're able to get root 9 times root 5. You can see there's separation, right? Why? So that I can get the perfect square of this 9. So when you take the square root of 9, you give us what? 3 divided by root 5. Root 5 you cannot get. So root 9 will give me 3, and then root 5 is that we cannot find root 5 as root 5 is a sword. So we have it to be 3 root 5 rather over 3. So this 3, we cancel this 3, and then we are left with what? Root 5. If you use division, it's very fast. That is if the number is divisible, because we can say root 15 divided by root 3. This one is divisible. You have 15 over 3, and 15 over 3 will give us what? Root 5. So, and that's that. It's either you divide if it is divisible, and if it's not divisible, then you rationalize. Please take note of that. So the next one is to use conjugate for binomial denominator. You use conjugate for binomial denominator. Let's see. Conjugate. What does conjugate mean? Conjugate is taking the inverse of sign of a particular number. Let's see what I'm trying to say. Is 2 plus root 3. The conjugate of 2 plus root 3 is 2 minus root 3. That is the conjugate. And if it is minus, it will change to plus. That's how to take the conjugate of a number. So let's look at this. Look at this example. We have 1 over 2 plus root 3. And remember, the rule 7 is that you must rationalize the sort. Sort must not be under your answer. Sort must not be in the denominator. Whenever you are solving sort and you get an answer, there must not be sort. There must be sort in the denominator. So you must rationalize. And for you to rationalize this, you can see we have 2 plus root 3. Then it means that you take the conjugate of this plus. So when you take the conjugate of the denominator, which is 2 minus root 3, what you will now do next is to multiply your conjugates. You know, in a rationalization, you multiply the denominator to both the numerator and denominator. If you remember, that is in our 7, in the root 7 here. You can see we multiply this by this. Okay, we multiply this root 3, multiply it by 15 and root 3. So the same thing is applicable to this. So you multiply the conjugate here to the numerator and denominator, and that is why we have 1 over 2 plus root 3 multiplying 2 it's multiplying 2 minus root 3, and 2 plus root 3 is multiplying 2 minus root 3. Then you see it here, 1 times 2 minus root 3 will give us 2 minus root 3 divided by, now this 2 plus root 3 is now multiplying 2 minus root 3 now. Okay, you take it step by step. Here you have to be very careful, because you have to expand this bracket. If you do not expand this bracket very well, you will not get it correctly. And if you have any difficulties in expanding this, please check my other video about expansion of brackets. Now 2 is going to multiply 2, that is 2 times 2 will give us 4, and 2 multiplied by minus root 3 will give us what? Minus 2 root 3. Then you come to this plus root 3 multiplying 2 will give us plus, because there's plus here and there's plus here, plus 2 root 3. Then coming to root 3 is now multiplying minus root 3, and this will give us minus root 9, because plus times minus will give us what? Minus. And that is how we have minus root 9. So with this now, we now have 4 minus root 9. How? Look at this. Minus 2 root 3 plus 2 root 3 will cancel each other out. It's as if you are saying minus 1 plus 1. If you interchange it to a 1 minus 1, and that will give you what? 0. And that is how we have 0 here. So we are left with 4 and minus 9, minus root 9 rather. So we now have 2 minus root 3, 4 minus root 9 divided by 4 minus root 9. Now this root 9, you can get the perfect square of it, and that will give us 3. And that's our mission. We have to rationalize. We have to make sure that there's no roots in this denominator, and we're able to get that done. We are now left with 2 minus root 3, 4 minus 3. There's no longer roots here. There's no longer roots here. So, and that will give us what? 2 minus root 3, and 4 minus 3 will give us what? 1. So the final answer here is 2 minus root 3, and that is correct. This one is correct. Okay, so that is how to solve SOD. That is how to solve SOD. Okay, please like, subscribe, and share Math Epson. Do visit Math Epson for any new topic. And if you have any problem concerning mathematics and you want me to explain or teach you or tutor you, you can do so by reaching me on WhatsApp on 070 35 56 74 74. Okay, you can reach me on 070 35 56 74 74 on WhatsApp. Then you can learn more about mathematics. Thank you very much. I appreciate your time in watching my video. Please always remember that I love you. And I want you to excel. Please stay safe and be happy. See you next time. Thank you.